Most teams think they are creating just a VNet. In reality, they are defining the constraints for every future workload that will ever live in this environment. A VNet is not a neutral container. It decides who can talk to whom, how the traffic flows, and where security boundaries exist, long before AKS, VMs, or private endpoints are even considered. When a VNet is designed ad hoc, every new workload feels like friction. Subnets start overlapping responsibilities, private endpoints appear as exceptions, and networks slowly become the bottleneck. This is why VNet should be treated as an intent-driven contract, not as a simple networking resource. What looks like just a VNet is actually the foundation of everything that comes next. This pattern usually starts innocently. We create a VNet, we added a subnet for now, and we deploy the first workload, AKS, a VM, or some PaaS services. At this point, everything works. The problem appears later, when the real constraints arrive. New subnets get added reactively, address spaces start overlapping, completely different responsibilities ends up mixed inside the same subnet, and once private endpoints, private APIs, or stricter security requirements appear, the network becomes extremely hard to change. This is the ad hoc subnet trap. It's not caused by bad Terraform code, it's caused by the absence of architectural intent at the network level. The most important shift here is not technical, it's conceptual. In ad hoc network design, subnets are treated as places. Subnet A is where something lives. Subnet B is where something else lives. That sounds reasonable until the system grows. The intent-driven design, a subnet is not about placement, it's about responsibility. A subnet defines what kind of traffic is allowed, what kind of workloads belong there, and what trust boundaries applies. Public ingress is not a subnet with public IPs. It's a controlled entry point. Private workloads are not internal resources. They are systems operating under strict, predictable assumptions. And private endpoints are not just connectivity tricks. They are explicit trust boundaries enforced at the network level. This shift from placement to responsibility is what makes a network reusable, scalable, and stable over the time. At this point, Terraform stops being a provisioning tool, it becomes a compiler. This input is not a list of resources. It's a declaration of architectural intent. We are not saying create 3 subnets. We are saying this network must support public ingress, private workloads, and application services separately. Terraform's role is not to decide how Azure implements that. Its role is to translate intent into a stable, enforceable contract. The module takes this intent, validates it, and produces a VNet layout. That stream systems can safely rely on AKS, private endpoints, PaaS services, anything that comes later. This is why modules matter, not for reuse, but for freezing architectural decisions early before workloads start depending on them. Before you deploy AKS, before you add VMs, before you connect any platform service, you must validate the network contract. This example intentionally deploys no workloads. That's not a limitation, it's the point. We are validating addresses space planning, subnets boundaries, responsibility separation, and long-term extensibility. If these assumptions are wrong, every workload you deploy on top will amplify the problem. A broken network foundation doesn't fail immediately. it fails later. When private endpoints appear, when scaling begins, or when security constraints tighten. This is why infrastructure design starts with contracts, not consumers. This design note was not about Terraform syntax. It was about architecture and intent. Real systems don't fail because of resources was missing. They fail because assumptions were just wrong. Network boundaries are not an implementation detail. They define what your system can safely become in the future. When intent is clear, Terraform becomes a compiler, not a collection of the resources. That's how private networking turns into production-grade, scalable systems.